There is a closed-loop system that produces 100 pounds of fish and 400 pounds of vegetables every single year for under $400 to build, and it requires no fertilizer, no soil, and almost zero ongoing cost. It uses 90% less water than conventional farming. It feeds itself. The fish feed the plants clean the water feeds the fish. Nothing breaks that loop. Nothing needs to be purchased to keep it running. The system does not degrade. It does not require seasonal restocking. It does not ask anything of you beyond an hour of attention each week. Yet while the $800 billion industrial food system sells us fertilizer bags, feed schedules, and chemical treatments that cost thousands of dollars every year, this system remains virtually unknown outside a handful of university labs and a few thousand backyard builders who figured it out on their own. So, what is it exactly? How does it work? And more importantly, why aren't any of us using this right now? To understand where this actually comes from, we have to go back to around 1200 AD in the Valley of Mexico, where the Aztec engineers of Tenochtitlan were facing one of the most difficult survival problems ever recorded. Their capital sat in the middle of a lake. They had no farmland, no soil, no room to expand, no trade routes reliable enough to feed 200,000 mouths through a dry season. The lake was not their obstacle, it was their solution. The engineers built a network of artificial floating islands called chinampas, constructed directly in the shallow water surrounding the city. These were not crude rafts. They were precision-engineered agricultural platforms layered with lake sediment, aquatic vegetation, and composted waste. Between those islands ran carefully managed channels filled with fish. The fish ate algae and insects that grew naturally in the water. Their waste fed the gardens above. The gardens filtered the water back into the channels below. The entire system fed a city of 200,000 people, the largest city in the Western Hemisphere at the time, with almost no external inputs and no dependence on rainfall or outside trade. Spanish conquistadors documented it with fascination when they arrived in 1519. Then they dismantled it entirely within a generation. They replaced the most efficient food system ever built with cattle ranching and monoculture corn. Across the Pacific, the same loop had been running in China since the Han Dynasty, over 2,000 years ago. Fish ponds paired with mulberry trees. Silkworm waste fed the fish. Fish pond mud fertilized the trees. Provincial governments documented these systems in agricultural records stretching back 1,000 years. The 20th century killed both traditions the same way. Industrialization made it faster and cheaper to buy a bag of fertilizer than to understand why your fish and your plants should live together. And what researchers discovered when they studied why this loop works so perfectly is the part that changes everything. Because the biology of what happens inside that water is something the $800 billion fertilizer and feed industry was specifically built to prevent you from ever accessing directly. In a functioning aquaponic system, there are three living actors working together permanently. First, the fish. Fish produce waste. That waste is pure ammonia, one of the most nitrogen-dense substances on Earth. In a conventional fish tank, ammonia accumulates until it poisons everything. It is why fish tanks smell. It is why fish farmers constantly dose with chemicals. The ammonia is treated as the problem. In an aquaponic system, the ammonia is not the problem. It is the entire point. Second, the bacteria. Nitrifying bacteria colonize every wet surface in your system within weeks. They convert ammonia into nitrites and then into nitrates. Nitrates are not toxic to fish, but nitrates are exactly what plants need to grow. Third, the plants. Roots suspended in that nitrate-rich water absorb nutrients directly. No soil, no fertilizer. The roots strip nitrogen from the water until it is clean enough to return to the fish. That is the loop. Fish feed bacteria. Bacteria feed plants. Plants clean water for fish. The Food and Agriculture Organization of the United Nations confirmed that aquaponic systems produce the same yield as conventional farming using 90% less water. Nothing evaporates. Nothing runs off. It circulates permanently. In the 1970s, NASA began researching closed-loop food systems for long-duration space missions under the Controlled Ecological Life Support System program. The goal was straightforward: feed astronauts indefinitely with zero resupply from Earth. Their researchers confirmed that aquaponic systems could produce continuous protein and vegetables in a sealed environment with minimal electricity and almost no purchased inputs. The reports were filed, the program was quietly defunded, And for the next 50 years, not a single mainstream agricultural institution referenced those findings in any public-facing research or extension program. The knowledge sat in archived government documents that nobody was directed toward and nobody was paid to promote. You cannot patent a nitrogen cycle. You cannot trademark the relationship between a fish and a bacteria colony. You cannot meter natural biology and send a monthly invoice for it. And for an industry built entirely around recurring purchases, feed bags delivered on a schedule, fertilizer runs every season, chemical treatments billed quarterly, that is not an inconvenience. That is an existential problem. The $800 billion industrial food system does not sell you food, it sells you dependency. Here is exactly how to build it. You need 3 components: a fish tank, a grow bed, and a pump. Nothing else is structural to the system. For a backyard starter system, a 300-gallon tank holds enough fish to meaningfully feed your family through the year. Buy one new for around $200 or find one used at a farm supply auction for $50 to $80. Inspect used tanks carefully for hairline cracks before committing. At full production, that tank yields between 60 and 100 pounds of tilapia or channel catfish per year, depending on your stocking density and feeding consistency. The grow bed sits directly above the fish tank and is filled with hydroton clay pebbles or clean crushed gravel. Either works. Hydroton is lighter and easier to handle. Gravel is cheaper and performs identically. A single 4x8 foot grow bed supports 30 to 40 plants at any time. Lettuce, kale, tomatoes, peppers, cucumbers, herbs. The University of the Virgin Islands documented lettuce reaching full harvest size in 28 days inside aquaponics systems, compared to 60 days in conventional soil. That is more than twice the production speed from the same square footage. The pump floods the grow bed on a simple timer. 15 minutes on, 45 minutes off. Water floods up through the bed, soaks the roots and drains back to the fish tank entirely by gravity through a standpipe drain. No second pump needed for the return. Gravity does that work for free. Total system setup cost lands between $400 and $700, depending entirely on whether you source components new or used. Cycle the system for 2 to 4 weeks before adding fish. Establish your bacterial colony first. This is the most important work you will do. Do not skip it. Stock tilapia at 1 pound per 5 gallons of water. Plant fast-growing crops first. Lettuce, basil, kale. Feed your fish once daily. Test pH weekly and keep it between 6.8 and 7.2. Then leave the system alone. It manages itself. The Aztecs knew this. The Han dynasty knew this. NASA confirmed it and filed the reports away. The biology has not changed. The loop still works. It is waiting in your backyard right now. Subscribe and share this with someone who is done waiting for permission. The food system will not fix itself, but your backyard can. And if you want to see how Persian engineers use the same principle of passive natural systems to cool entire cities without a single watt of electricity, that video is right here.